Okay, we are in Chapter 7, Section 5, and before we delve into it too far, we're going to start these little diamond puzzles. And what a diamond puzzle is we need to figure out what two numbers multiply to give us this top thing and add to give us the bottom. So we're going to take the product of the two numbers and think about all of the possible factors of that. Now, if we're adding to get a positive, that means that our factors, the bigger one would be positive. So this would be like 14 times negative 1, 7 times negative 2. And we actually already have our answer because a positive 14 and a negative 1 adds to give 13. So our two answers are 14 and negative 1. That can be in the opposite order. It doesn't matter which order. Okay, the next one, two numbers that multiply to give 12 and that add to give 8. So here's 12. Since it's a positive 12, we're just going to write out our factors of 12. 1 times 12, 2 times 6, 3 times 4. And which of these adds to give 8? 2 and 6. So 2 and 6 are our two answers in whichever order. Two numbers that multiply to give negative 24 and that add to give negative 5. This time the bigger number is going to be negative. So that's 1 and negative 24, 2 and negative 12, 3 and negative 8, and 4 and negative 6. We have our answer. That adds to give negative 5. So 3 and negative 8 are what would go side by side. Either order is great. Two numbers that multiply to give 42 that add to give 43. So if you think about your factors of 42, 42 and 1, we can actually stop right there because that adds to give 43. So 42 and 1 or 1 and 42. And we're just going to practice these so that when we get to factoring in the near future, it is easier. All right, a monomial is one term. So the number, any number is a monomial, like 5, that'd be a monomial. X, that'd be a monomial. 5x, that would be a monomial. That's multiplication. 3x squared, y, that would be a monomial. All of those are monomials, one term. Things that are not monomials is when you see an addition or a subtraction, like x squared plus x. That's actually a binomial because it has two terms, which we're going to get to in a minute. So if there's a plus or a minus, breaking it up, it breaks it up into different terms, unless you have like terms that you can put together. Like if you have 6x plus 3x, you would need to simplify that to 9x, and that is a monomial. All right, division by a variable is also not a monomial. So if you have a letter in the denominator, not a monomial. And if you have a negative exponent or a fraction of exponents, like x to the negative 3 or x to the 2/3, those are not monomials. So if you look at these, let's circle the monomials. That's a negative exponent, so that is not. Yes, yes. Binomial, that's two terms. Yes. Yes, because that's like a 1/2 x, and this is not because these are in the denominator. Okay, the next thing we're going to talk about is degree. So you're going to decide if something's a monomial, a binomial, a trinomial, and then you also need to figure out the degree. The degree typically helps figure out how many x-intercepts there are. So to find the degree, you look at your exponents. So this is a 2, and this is a 4, and you add them up for each individual term. So this is a 6th degree. In letter B, there's no letters, so it's kind of like an x to the 0. So this is a 0 degree. Okay? A y alone is like a y to the 1. So this is the first degree. And in this one, we're adding the 5 and the 1. So this is the 6th degree. And those are all monomials because they're all one term. All right, now we've got binomials and trinomials. Binomials means there's just one plus or minus sign. This breaks this up into two terms. This minus breaks this up into two terms. In fact, if you want to find the degree, I won't get ahead yet. Okay, trinomial. So there's two pluses or minuses. So this is a term, this is a term, and this is a term. There's three terms separated by two pluses or minuses, so that's a trinomial. Same thing here. One term, separation. Second term, separation. Third term. Since the letters, the variables are not the same, there's no like terms, so those are in fact three separate terms called a trinomial. So now we're going to find the degree, and we're going to also, well, the first one is a trinomial because there's three terms. And then this next one is just a polynomial. Anything over 3, we're just going to call it a polynomial. There are quartic and quintic, but I think that's the next slide. So, the degree. This degree is a 3 and a 2. So this monomial right here is a 5th degree. This monomial right here is a 2 plus 1, so that's a 3rd degree. This monomial right here is a 0 degree. So the degree of the polynomial is the biggest degree that there is. So this trinomial is a 5th degree. All right, if you look at the polynomials, this one is a 3rd. This one is also a 3rd. That's a 2nd degree. And this is a 3rd degree. So this polynomial is a 3rd degree. Now, typically, you look at the x variable and you put them in order with the x. So this is the biggest x exponent, so we're going to write that first. So that whole negative 11 x to the 4th goes first. The next biggest x exponent is the x cubed. So that's a positive x cubed y squared. The next biggest x exponent is the x squared. Don't lose that negative outside of the 4. Instead of making it a plus, you could just make it a minus. Next in line is the 7x. And last is the minus 3. So this is the proper order of this polynomial, which happens to be 5 terms. Now, the leading coefficient is the number in front of the leading variable. So we need to put these in order. So this would go first because it's the biggest x exponent. You're picking a letter to put these in order with. It's not degree order, it's like usually by x. So the next biggest x exponent is 4x squared, and then 6x, and then 9. So the leading coefficient is that negative 7. And what the leading coefficient tells us, like if you have a line, and if you have a 1x, that tells you that it's overall positive. If you have a negative 1x, that tells you that it's overall negative. So the leading coefficient is very important in telling you if you have a positive or a negative graph. Here, the y to the 6 would go first, and then the y squared, and then the 3y. So the leading coefficient, we could put a 1 in front of this. The leading coefficient is 1. So when there's no coefficient in front of the letter, you can put a 1 there, and it means the same thing. So essentially, we've got, this is a little table here. So if it's the first degree, it's a line, that's like an x. If there's no letter, just a number, that's a constant. An x squared is a quadratic. An x cubed is a cubic. An x to the 4th is a quartic. And an x to the 5th is a quintic. And then if there's one term, it's a monomial. 2 terms is a binomial. 3 terms is a trinomial. And anything more than that, we can just call a polynomial. So let's go ahead and classify each of these. 5n cubed plus 4n. This is 2 terms. So this is a binomial. And the degree, this is a 3rd degree, this is a 1st degree. So it's a 3rd degree. That's the biggest number. And then in the next one, these are already in order. This is 4 terms, so we'll call this a polynomial. And this is a 6th degree, a 3rd degree, a 1st degree, and a 0 degree. So it's a 6th degree. Just a little extra here. If you have an x equation, your line goes like this, where the end behavior is in the opposite direction. And then if you have an x squared, overall your line's going to go like this, where your end behavior is in the same direction. And what keeps happening is if you have an x cubed, your end behavior is in the opposite direction. X cubed looks just like a line, but if there's more stuff to it, there's like this little jump in the middle. And so your end behavior is in the opposite direction. The same thing goes with an x to the 4th. An x to the 4th is going to look like this. If you have a bunch of more stuff with your x to the 4th, it's going to end up having up to 4 x-intercepts. See how this could cross up to 4 times? It might cross less, but it can't cross more. And this one can cross up to 3 times. And then it just keeps going, like an x to the 5th looks like an x cubed. An x to the 6th looks like an x to the 4th. So, something to think about, might help you in the future. Okay, have a good night. See you tomorrow.